Hello everyone. Today we'll be solving AQA GCSE Chemistry, Paper 1, June 2019. Guys, this is a part 3 video, and in this video we are solving from question number 7 to question number 9. This question is about electrolysis. Aluminium is produced by electrolyzing a molten mixture of aluminium oxide and cryolite. Explain why a mixture is used as the electrolyte instead of using only aluminium oxide. So basically, aluminium oxide has a very high melting point. All right. So when we add impurities, impurities are able to decrease the melting point. So less amount of energy will be needed if we use a mixture. What happens at the negative electrode during the production of aluminium? All right. So in the negative electrode, positive ions are going to come. Aluminium ions are going to be there, and aluminium ions are going to gain electron, and they're going to turn into aluminium metal. So we can say when it says aluminium atoms, then it's going to be wrong. And they gain electron, this is the one which is correct. Oxygen is produced at the positive electrode. Complete the balanced half equation for the process at the positive electrode. So in order to produce a O2, we will require two O2 minus because it's oxide ion at this stage. So once it turns into a O2, each O2 minus must lose 2 electrons. So 2 O2 minus must lose 4 electrons. Explain why the positive electrode must be continually replaced. So basically, the positive electrode is the one that is producing oxygen at a very high temperature. And the positive electrode is itself made from carbon. So what happens is that the oxygen that is produced at high temperature, it reacts with that carbon and it turns into carbon dioxide, which escapes as a gas. So the carbon electrode gradually gets eaten away, and that's why it needs to be replaced. The overall equation for the electrolysis of aluminium oxide is aluminium oxide turning into aluminium and oxygen. Calculate the mass of oxygen produced by 2000 kilogram of aluminium oxide is completely electrolyzed. Guys, in a question like this, we will have to calculate the MR of aluminium oxide first. So MR Al2O3. Since each aluminium has a mass of 27, we're going to multiply it by 2, and each oxygen has a mass of 16, we're going to multiply by 3, which will give us a total of 102. The next step will be to find out the number of moles. So we'll write number of mole. And what we are finding the number of mole for? Aluminium oxide. So we're going to write number of mole Al2O3. And then we are going to divide the 2000 kilogram. We're going to also multiply this 2000 with 1000 so that it is converted into grams. And then we're going to divide it by 102, which gives us a 19608 mole. Guys, the next step will be that we are going to find out that how many moles of oxygen are produced from this amount of aluminium oxide. Now you see the stoichiometric ratio is 2:3. That means we will find out number of mole O2. Number of mole O2 will be 19608 divided by 2 multiplied by 3, which gives us 29412 moles of O2. Next, we are going to find out the mass of the oxygen. Okay. So, mass of oxygen. Now, you see, in order to find out the mass of oxygen, we will multiply the number of mole with molar mass of oxygen. Now, each oxygen is 16. So if you multiply by 2 for O2, it's going to be 32. So it's going to be multiplied by 32. Then we're going to divide it by 1000 so that we can get it in kilograms. So the answer will be 941. Sodium metal and chlorine gas are produced by the electrolysis of molten sodium chloride. Explain why sodium chloride solution cannot be used as the electrolyte to produce sodium metal. Guys, in a sodium chloride solution, we have the ions present, sodium, chloride, and also because it is a solution, it contains hydrogen ion and hydroxide. The main problem is when hydrogen ion and sodium ion, since they are both positive ion, they compete according to their reactivity in the reactivity series. And we know that sodium is highly reactive, which is why hydrogen is the one that gets released first. That's why, guys, hydrogen is released first, and that's why we cannot use a sodium chloride solution. So the answer will be written as follows. Calculate the volume of 150 kilogram of chlorine gas at room temperature and pressure. The volume of 1 mole of any gas at room temperature and pressure is 24 dm cube. The relative formula mass is 71. So, guys, in order to do this math, first of all, we need to find out the number of moles. So, 150,000, because when we convert the kilogram, it is multiplied with 1000. So, we will find out the number of mole of chlorine. So, 150,000 divided by 71, which gives us 2113 mole of chlorine. Now, since each mole is occupying 24 dm cube, so volume of chlorine will be 2113 times 24, which is equals to 50700 dm cube. Copper forms two oxides, Cu2O and CuO. A teacher investigated an oxide of copper. Figure 10 shows the apparatus. Tube A, oxide of copper, we heat it and we are putting in hydrogen. Tube B, we have a drying agent and excess hydrogen that is coming out from here is burning off. So the drying agent will remove the water vapor. This is the method used. Weigh empty tube A, add some of the oxide of copper to tube A. Weigh tube A and the oxide of copper. Weigh tube B and drying agent. Pass hydrogen through the apparatus and light the flame at the end. Heat tube A for 2 minutes. Reweigh the tube A and contents. Repeat step 5 to 7 until the mass no longer changes. Reweigh the tube B and contents. Repeat step 1 to 9 with different masses of oxide of copper. Suggest one reason why step 8 is needed. Okay, guys, let's repeat the step 8 again. So, repeat from 5 to 7 until the mass no longer changes. Guys, we want to make sure all the oxygen that was combined with the copper oxide, all the oxygen from that copper oxide is reacted. So we want to make sure that all of them, the reaction is complete. Since we want to make sure that the reaction is complete, that's why we need to do repeat the process. Explain why the excess hydrogen must be burned off. Excess hydrogen must be burned off to prevent the hydrogen from escaping into the air. And, hydrogen is very explosive, so that can be a hazard as well. Figure 10 is repeated here. All right, so we have tube A again, and we have tube B, oxide of copper. All right, tube A, empty, 105.72, and we have the other masses that we have recorded. Okay. All right, at the end also we have recorded the mass. Okay. When an oxide of copper is heated in a stream of hydrogen, the word equation for the reaction is copper oxide plus hydrogen produces copper plus water. Great. Determine the mass of the copper and the mass of the water produced in this experiment. Okay. So to find out the mass of the copper with tube A and oxide of copper before heating, so we can see if we can find out the mass of the copper oxide from here. All right, we can 115.47, we can subtract 105.72. Okay, and then tube B, tube A contents after 6 minutes. We can see what mass has decreased. So 115.47, all right, minus, all right, we can see 114.38. So because, all the oxygen has already gone away, all right, so this will give us the mass of the oxygen that is actually gone from here. So if we know the mass of copper oxide from here, and we know the mass of oxygen from here, so we can do a subtraction to find out this one. So guys, mass of copper equals to guys, this is equals to 8.66 gram. And guys, if we want to find out the mass of water, it's going to be a little bit more simpler. So tube B at the start, 120.93, and tube B at the end, 123.38. So 123.38 minus 120.93. Guys, this will give us the mass of the water. So the mass of the water is 2.45 gram. The teacher repeated the experiment with a different sample of oxide of copper. The teacher found that the oxide of copper produced 2.54 gram of copper and 0.72 gram of water. Two possible equations for the reactions are Cu2O plus hydrogen and CuO plus hydrogen. Determine which is the correct equation for the reaction in the teacher's experiment. Guys, this is a very nice question. So in order to find out, we need to first of all find out the we need to find out the number of moles of copper. Guys, then we are going to find the number of moles of water. We will divide water is H2O, so it's 16 plus 2, which gives us a value of 0.04. So guys, we can see that both of them are in 1:1 ratio, which means this example equation 2 should be correct because it is also in 1:1 ratio. A student investigated the temperature change in the reaction between dilute sulfuric acid and potassium hydroxide. Measure 25 cm of potassium hydroxide solution into a polystyrene cup. Record the temperature of the solution. Add 2 cm of dilute sulfuric acid. Stir the solution. Record the temperature of the solution. Repeat steps 3 to 5 until 20 cm of dilute sulfuric acid has been added. Suggest why the student used a polystyrene cup rather than a glass beaker for the reaction. Guys, the main reason why we're going to use a polystyrene cup is because it's a insulator. A glass beaker, glass is not a very good conductor of heat. However, glass by itself will absorb a quite good amount of heat energy. So that's gonna create a discrepancy in our answer. So that's why we're going to be using a polystyrene cup. Table 6 shows some of the students' results. So we can see the volume of sulfuric acid added, and we can see the temperature after the addition. Show some of the data from the figure 11 shows some of the data from the investigation. So you can see volume of sulfuric acid added in cm cube and temperature in degrees Celsius. The trend is like this, okay. Plot the data from table 6. Draw a line of best fit through these points. Extend the line of best fit until they cross. So table 6, 0, 18.9. 2, 21.7. Sorry, that's my bad. Oh, no. So we have to also extend the line of best fit until they cross. Determine the volume of dilute sulfuric acid needed to react completely with 25 cm³ of potassium hydroxide solution. So to react completely with 25 cm³ of potassium hydroxide solution, our answer would be the point where it crosses. So volume of sulfuric acid needed would be 11. Determine the overall temperature change when the reaction is complete. So to find out the overall temperature change, we'll find out the highest temperature reached. The highest temperature reached here, we can find 27.6, and the starting of the experiment we had 18.9. So 27.6 minus 18.9. So the overall temperature change is 8.7. The student repeated the investigation. The student used solution that had different concentration from the first investigation. The student found that 15.5 cm³ of 0.5 mole per dm³ dilute sulfuric acid completely reacted with 25 cm³ potassium hydroxide solution. Potassium hydroxide, sulfuric acid, potassium sulfate, and water. Calculate the concentration of potassium hydroxide solution in mole per dm³ and in gram per dm³. So when finding out concentration, guys, first of all, if we try to find out moles of H2SO4, because we have used 15.5 with 0.5 mole per dm³, so we can find it out. When finding moles, it will be volume into concentration. So the volume is 15.5. Because the volume is in cm³, so we need to convert it into dm³ by dividing it by 1000. And then the concentration is 0.5. So this gives us 0.00775 mole. Now, obviously, whatever the moles for sulfuric acid, 2 times that will be the mole for potassium hydroxide. So we will say moles of KOH. we will just simply multiply it by 2 into 0.0775. Now we want to find out the concentration of KOH. When finding concentration, it is always number of moles divided by volume. So N divided by P. So the number of mole is 0.0155 and the volume is 25 cm cube. So which is 25 over 1000. The reason why we're dividing by 1000 is we want to convert it into dm cube. So the answer is 0.62 mole per dm cube. Okay, guys, now we got the, mole per dm cube. We need to know the gram per dm cube. So for finding the gram per dm cube, we need to first of all find out the MR of KOH. So potassium has a value of 39, oxygen 16, and hydrogen 1, which gives a total of 56. Now, in order to find out the mass, we'll have to multiply 0.62 times 56, which will give us gram per dm cube, which is 34.7 gram per dm cube. Guys, that's the end of this particular question paper. Thank you for holding up until this long. Guys, question paper like this will be uploaded every day. So please subscribe to the channel and support the channel so that the channel can grow. All right. And it comes in your help. Thank you for watching the video. Best of luck for your exam. See you in the next video. Bye-bye.